Confusing models and reality. I read an article recently in which the author suggested that data mining and analytics combine many data sets together to create new facts about individuals. A few days later, I sat through a product briefing where the presenter said that a linked list was a graph. Both of these are examples where someone has mistaken a representative model for the thing that it models. This line of thought not only betrays a limited understanding of modeling, it is also the preliminary step into a slippery slope that ends when a person actually believes that the data is truth. Let's think about this for a moment. I will put on my mathematics and computer science hat and start with the second example. A graph is a mathematical abstraction describing a set of items called nodes or vertices and connections between these nodes, which are called links or edges. On the other hand, if you're familiar with some basic computer science, you know that a linked list is a data structure that can be used to concretely implement a scheme for mathematic or algorithmic concepts. For example, a linked list can be used to represent a list of items, or a set of items, or a search tree, or a graph. However, the linked list itself is not a graph, nor does it carry the characteristics of a graph. In essence, calling it a graph betrays two levels of abstraction. First, that a data structure can be engineered to model the building blocks to represent abstract structures, and second, that those building blocks are used within an application to represent the specific abstraction of a graph. Equating the two is like trying to drive a lump of clay because it can be used to create a model of a car. The first example, in which analytical results are perceived to establish facts, is a little bit more serious. It presumes that an inference about an object discovered as a result of data analysis is as valid as a fact about that object. In some cases, the inference is insightful and can be used to influence decisions or decision processes, but in the absence of real validation, it's unwise to treat the inference as fact. We have to remember that models are just that, models. A model is an attempt to capture the core characteristics of the real-world item that it models. However, the model is just a reflection bound in time of a real-world item. And once the model has been instantiated, the real-world thing goes about its busy day without necessarily alerting anyone that the model itself requires updating, or that aspects of that thing have incrementally changed over time, or that the thing looks different, smells different, or goes by a different name. But if you begin to confuse the model with its real-world equivalent, you run the risk of making incorrect and potentially damaging assumptions. The upshot is a data model is only as good as its synchronization with real life. And we must always remember to distinguish between the model and the real-world item it represents. I'm David Loshin from Knowledge Integrity. Thanks a lot.